Welcome to your second to last day of instruction in calculus. Yeah, we have today and tomorrow. So today we're going to take a look at general solutions to differentials. And tomorrow we will look at specific solutions to differentials. Okay? So basically today we have a plus c, the constant. Tomorrow we eliminate that. All right? So quick jog your memory. A differential is a derivative, right? So you're given a derivative. The question is, last week we graphically found the solution with slope fields, right? Yeah. This week this is an algebraic solution. So we're going to find the actual original equation. Okay. So general solution to a differential is find the equation. Okay. Here's the problem. These usually look pretty ugly. Okay. Do you remember implicit differentiation? Where there's an x and a y together? Okay. This is not the equivalent of that because we don't have to do the y's and x's together. We split them apart. If you can't split them apart, you can't do anything with it. Okay? So the first thing you have to do when you're solving a differential is separate the variables. Put the y's on one side and the x's on the other. So we split them up, it makes it easier instead of trying to do it all at once. Okay, so how do I move the y to the left side? Yeah, you're going to multiply by y. And how to move the dx? No, it's divided, so we multiply it around as well, right? Okay, so what we end up here is y dy equals negative x dx. Okay. That's the only thing that you haven't done already this year, separating those variables. Okay. Now how from here, how do you undo a derivative? Yeah, inside the right, integrate both sides. Okay. But again, we separated the variables, so these should be pretty easy. I'll show you a hard one, but what's the antiderivative of this? Yeah, of y. Y squared over 2. We're missing something. No. Thank you, Kira. Okay, these are indefinite integrals. There's no numbers, correct?
Will we put a plus on both sides?
Oh. What if we did that? What happens? Yeah, they cancel out. Okay. So we are technically correct, but we would want to put a different letter here if we did. Okay. So, but it doesn't matter because that b is going to come over here anyways and be with this number, right? You're going to combine those numbers. So all you need is one constant. Okay. So don't worry about doing that. Just one c is enough. Okay?
So you just anti-derived.
Yeah. And then this now an algebra problem, solve for y. So separate variables, integrate, and solve for y. So what would you do? Algebra. What's the first step here? Elise, you seem to be focused. What do I do to solve for y? Okay, that's the first step. So y squared equals negative x squared plus 2c. And now we root, right? Don't forget, it's going to be positive or negative. Okay. There you go. You've just found the general solution to that differential. Yeah, it is, actually. It's math. What else is there in life? If you want to make life all fun and games, you'd be a math major. Thanks, Jordan. Okay, just a quick note. If this is a multiple choice problem, they might just write that plus c. So when you get to tomorrow, you'll see why. When we get to specific solutions to differentials, you'll see why this does not matter. But in multiple choice, you can throw that in there. Don't let it confuse you. As long as there's a letter there for the constant, that's all you need. Okay. That number will turn out the same either way. Okay. Okay. Let's try that one. We have to rewrite it first. Maybe not rewrite that so we can separate it.
No.
In pre-calc, we just did exponent properties. What happens when the exponents are subtracted? Yeah, you divide. So what would the rewrite be? U to the x over e to the y. And then subtract. Ooh, that's ugly. Okay, so that's the rewrite there. Now separate. Okay, separate on your paper, and then we check. Okay, I waited. I guess I'm still waiting. 2 seconds. 3 seconds. Kylie, what's your separated variables look like?
E to y to y equals to the x to x.
Yeah. Okay, the next step. What'd you get? Very good. It's the easiest one we can give you. E to the y equals. Yep. And solve for y. What? Well, what's the inverse of and an exponential. Yeah, log, base C, so natural log. So we're gonna. Right. So this would be y equals natural log.
Where did the,
Okay. So there's your general solution. Any questions? Let's look at one more or two more. Oh, that's where this is going to come up. How about that one? Go. Do it. You can do it. Just do it. You separate, you divide by y. Antiderivative. You just did it. You're close. We get the opposite value. We didn't have to have it on that one, on the warm-up, because 2 is positive, right? Okay. So here we do, though. So don't forget that. You will lose a point on a free response if you forget it. Now solve for y. Not multiply by e. It's an exponential, so to the power of. Those cancel out. Tomorrow we'll talk about getting rid of absolute value there. But we can't do that without a specific solution. Okay, this is not going to be how a multiple choice answer is formatted. Okay. So you have to use your exponent properties. Can I rewrite it like that? Added exponent means we can multiply with the same base, right?
Yep.
Is this in fact itself just a constant, a number?
Yeah.
Yes. Okay, so we can write, the multiple choice answer here would be this.
C-E.
KB. Oh, sorry. I went into some other format here. X squared over 2. I went logistic on you.
So that's like, what is C?
This is the answer.
I'm gonna look at one above it.
Yes, so remember you can split that, added exponents into similar bases multiplied.
Oh, yeah.
But this right here is just a number. So we can just say it's C. And move it up front. So the C is just, there's just a little nuance there in formatting. It's not a big deal, but it doesn't confuse you. Any questions there? No. Good. Okay. Do you want to see the harder one? It's that right there. You gonna do that one?
Maybe you do the show me.
I'd like to see it.
They're right smaller. There's not a lot of room on that paper. Okay, so let's separate. And then we'll get- Okay, this one you can do. And this one you can also do, but what technique do we have to use? Have to use some.
So it's sine x at 30
No. What's inside something?
x at 30.
Okay, this is inside of sine, so that's your u value. Again, what's the derivative of x cubed? X squared, right? It's out there, so those are your two clues. So u is x cubed. It means the derivative is. So move this right up. So we end up with 1/3 sine of u, right? And what's the antiderivative of sine? Negative cosine. Just make sure you plug back your x. And then square root. So it's the same process, you just have to use substitute in the integral instead of having a straight up memorization problem. Any questions?
So what exactly is this calculated?
What?
So what is that calculated? Like as far as gravity, what that is like?
The slope fields.
Yeah.
So yeah, the slope fields, Remember, if that's your differential, algebraically, it didn't. My X's are now tails. So if you're doing a slope field equivalent here, you probably have something like this, that, see how it would mimic the sine curve? So that's what your slope field would look like. But we don't, because we have a constant here, it's a slope field because we cannot place where that curve goes. That's the relationship between those. Tomorrow, we figure out this plus C, and you can place it specifically on the graph. Okay, so tomorrow's everything ties together in a specific way. Cool. Any other questions? So we are in 9.1 in the book for this one. Six problems. So, yeah, this is in the book. We'll look at that tomorrow. Do specific solutions. Then Thursday and Friday we have to do NWEA testing. No, not done with it. But what it does mean is you'll get 2 days to do tomorrow somewhere. But this is due tomorrow. Okay.
Does that count as a contributor?
Just FYI, I have surgery on Monday again, so probably will not be here Tuesday. Just probably. It's outpatient, so.